Hello, good morning, everyone. So yesterday we have discussed about CCNA topics. So today we'll be starting with routing. So what do you mean by routing? Selection of best path. Yes. What do you mean by routing? Two different networks. Okay. So it is a process of finding the best path or optimal path to reach to your destination.
एक चीज चेतन, I need to ask one thing. There is multiple in CCNP, NRC and NCorp, right? Two courses are there. So all the routing protocols are same, right? Or is there any difference?
No, same. Routing
Oh.
protocols are the same.
Okay. So that other NRC you will cover or some other guy will cover?
I'll only cover that.
Okay.
So okay, moving on. So if you talk about routing, so routing can be done two ways. One is static, one is dynamic. So if you talk about dynamic, again dynamic is subdivided into two parts. Not me. What are the two parts? IGP and EGP. So interior gateway protocol, and we have exterior gateway protocol. So IGP is again subdivided into trip. We have EHRP, we have OSPF, and we have IS. So if we talk about EGP, we have only one protocol, that is BGP. So in static routing, we'll be seeing how to create directly connected static route. We have recursive static route. and we have fully specified static. So what do you mean by interior gateway protocol? Yes.
Sir, within AS.
IGP we use within an autonomous system. Whereas EGP in between two different autonomous systems. Done? Okay. So today we'll be finishing with static routing. So we'll see directly connected static routes. What do you mean by recursive static route? And what do you mean by fully specified static route? And finally, we'll be seeing what do you mean by default route. Okay. So now,
What is the last which you write down? EI?
default.
Okay, default. Okay.
Done? Now, what do you mean by static routing? So let us consider we have R1, we have R2, we have host 1, and we have host 2. So let us consider the IP between host 1 and R1 will be 192.168.11.0/24. This is dot 1, this is dot 2. So the IP address between R1 and R2 will be 192.168.12.0/24. This is dot 1, this is dot 2. And the IP address between R2 and host 2 will be 192.168.22.0/24. This is dot 2 and this is dot. Okay. So now let us consider host 1 wants to reach to host. So what will be the source IP? 192.168.11.1. What will be your destination IP? 192.168.22.1. Now, so if you talk about your host 1, host 1 will never know the network 12.0 and 20.0 because your host 1 will always be knowing the IP address of default gateway. You need to go to the host 1 and provide the manual default gateway. Done. So let us consider the MAC. Host 1 is A, B, C, D, E, and F. Now, talk about source MAC. What will be the source MAC? Source MAC will be A. Now, what about destination? So destination MAC, I don't know of the default gateway. What will put? So ARP request will be always broadcast. FF is broadcasting, so it will reach to the default gateway. So what will be the ARP reply? ARP reply will be source MAC will be B and destination MAC will be A. Correct. So one ARP request here. ARP reply back to host 1. Now host 1 knows how to reach to the default gateway. Now we will remove this destination MAC. What will be the destination MAC? We'll put it as B. Done. So now host 1 is able to reach to the default gateway. So now what about R1? What about the router? Will router forward the packet? Router is by default a broadcast controller. So what do you mean by that? So if you see the entries in the routing table, R1 will be having only the directly connected entries. So if we talk about the routing table of R1, we need to show IP route. So D 192.168.11.0/24 directly connected. What is the interface? So let us consider the interface as G0 bar 0. This as G0 bar 1, G0 bar 0, and G0 bar 1. So what will be the exit interface? The interface will be G0 bar 0. And router will be having one more entry directly connected, that is 192.168.12.0/24 directly connected, that is G0 bar 1. Now, so when the host 1 pings to 22.1, now what router will do? What is the destination IP? 22.1. So what by default the routers will do? Routers will do the destination lookup. So as soon as R1 checks its routing table, I don't know how to reach to 22.1. It will drop the packet. So I don't know how to forward, right? So you need to have an entry in your routing table, either statically or dynamically. Now let us consider we created a static route. So now, so talk about static route, how to create that. So let us consider you have created a static entry for the network 22.0/24. What will be the next stop? Next stop will be, because R1 knows how to forward the packet to R2. So let us consider the next stop as 192.168.12. What is the interface? You need to exit from which interface? You have to exit from this interface. Now, one more key point to remember, your source IP and destination IP will never change. This is fixed. Only your source MAC and destination MAC changes on each and every segment. Now, so now the packet has reached to R1. Now R1 will check in its routing table. So what is the next stop? Do I know how to reach that next stop? Yes. So what is the source IP? Source IP will be what is it again? 11.1, 20.1. But ARP request. So it will send a ARP request to get the MAC address of 192.168.12.2. This time the source MAC will be, so let it be there. So source MAC will be, I don't know the destination MAC. Again, ARP request is always a broadcast. FFFF, so it will reach to R2. So R2 will send a ARP reply. So in ARP reply, what will be the source MAC? Source MAC will be D and destination MAC will be B. Now he knows the source MAC D. Now he will put the entry. Now he will forward the packet to R2. Now R2. What about R2? So if you check the routing table of R2, R2 will be having two entries. So directly connected 192.168.12.0/24. Directly connected. What is the interface? It is Z0 bar 0. And it will be having one more entry 192.168.22.0. Sorry, it will not be D, it is C. Connect. So it is for EIGRP. Okay, so 20.0 directly connected. What is the exit interface? Exit interface will be Z0 bar 1. Sorry, 0 1. Now again a ARP request. Again a ARP request. So now it will resolve the MAC of the host. So now what will be the source MAC? And destination MAC will be. So R2 will check its routing table. I know how to forward this because it is directly connected to me. Now he will forward the packet with the exit interface. And the packet will reach to host. So now what about the reply? Host 2 needs to reply to host 1, right? Then only your ping will be successful. Now, when host 2 sends the reply, what will be the source IP? Source IP will be 20.1. What is the destination IP? 192.168.11.1. What about source MAC and destination? This time host 1 knows the MAC. It has resolved already. Now source MAC will be F and destination MAC will be E. We'll forward the packet to the default gateway. So now what about R2? R2 knows how to reach to 11.0. No, it will drop the packet because I don't have an entry in my routing table. Correct? Correct, right? So what about R2? R2 has only directly connected routes. Can you see here? I know only how to reach to 12.0 and 20.0, but I don't know how to reach to 11.0 network. So this can be achieved either by static routing or default routing. So in today's class, since we are discussing static routing, we'll create an entry static. So I'll show you how to create this entry. Then we'll create a static entry for 192.168.11.0/24. What is the next hop? 192.168.12.0. Sorry, 12.1. What is the exit interface? Exit interface will be C0. Correct? Now, what will be the source MAC again? It will be D, it will be C. Your packet has reached to R1. In R1, it will check the routing table. This network is directly connected. So it will forward the packet to host 1. So that's how the packet flows. So one key point to remember, always your source IP, destination IP will never change. Only source MAC and destination MAC change. Very key point in the interviews. Clear? Any doubts? Yes, online guys, any doubts?
So this one is the packet flow between host 1 and 2.
Yes.
Okay.
The source map will change the IP.
Every segment.
Every segment.
every
It's like, is there any seconds for timing timer for that?
So ARP is there. ARP entry we have a timer by default 24 hours. ARP
Okay.
entry.
ARP because it's
Routing table, no. Statically or configured. There is no, until unless you go and remove the static entry, that will be present in your routing table.
only source IP and destination map will be fixed.
Yes.
So, that will be like for that also timing is a 24 hours.
Which one?
Source IP and destination.
No, that is by default present. Directly connected. It's directly connected to R1. Until unless you remove this link, it will be there in your routing table. Otherwise, if you go and manually shut down, administrator down. Clear? Now AD value. So what do you mean by AD?
That's administrative distance and trustworthiness of any route.
Good. So administrative distance. So what do you mean by AD? It tells us the trustworthiness of our route. AD value can be 0 to 255. 8-bit number. So least AD is the most preferred one. Least AD is the best one. Not best, preferred. Can anybody tell me what is the AD value for directly connected? 0. What about AD value of static route?
1.
1.
Done? Okay. Now, how to create static route? First is directly connected. We'll be using our exit interface. I'll show you in the lab why we call it as directly connected. So how to create this? So the command is you have to go to global config. Let's consider we're configuring on a router. Go to the global config mode. So it is IP route. The network IP, subnet mask, and exit interface. Please make a note. The exit interface.
Is this done?
Then anything is there. INTER FAC.
This one, R, configure.
Router. R means router. Sorry. Router. Yeah. Short form is R. Or you can provide the host name as well. So second type of static route is recursive static route. We'll talk about recursive. So we'll do the lab. Why we call it as recursive? So we'll be mentioning our next. So how to create this? So IP route, network IP, subnet mask, next hop IP. Very good. Next hop IP.
You mean with recursive static route when we are typing with the next hop, right?
Yes.
That is called recursive.
Yes. So recursive means, I'll tell you, it will do the double lookup. I'll talk about this when we configure in the lab. So why we call it as recursive? Done. So one more type of static route we have fully specified static route, where we'll specify both the exit interface and next hop. So it is IP route. First, you need to specify the exit interface and then the next hop. Done. Done. Yes, done. Online guys.
Yes.
Okay. So now we'll move on to the lab. So we'll create a lab and I'll give a task as well at the end. So please finish the class and submit it. If anybody doesn't submit the class, no task, no class. So let us consider. This is the lab setup. We have R1. So we have R2 and we have R3. Taking a switch. Normal layer 2 switch. and two hosts are connected. PC1 and we have PC2. So on the R3, here to switch. I hope everybody knows how to assign the IPs to the interfaces. Yes, online guys?
Yes, sir.
Everybody knows, right? More than it. So PC3 routing is done. If you know how to assign the IP address. So we have PC. So between R1, PC1 and PC2, so the network will be 192.168.1.0/24. And between R3, PC3 and PC4, the network will be 192.168.2.0/24. So this will be dot 100. Can you tell me the network ID, broadcast ID, and subnet mask of this? Sorry, valid hosts of this?
That is start with 192.168.1.02254.
0 to 254. Can I assign 0?
No.
No, this is your network. 255 is your broadcast. So between 1 to 254, you can assign it to your host. So PC1 will be dot 1, PC2 will be dot 2. Then the IP address between R1 and R2 will be 192.168.12.0/24. This is dot 1. This is dot 2. So the IP address between R2 and R3 will be 192.168. Always lower router number first and higher router number, so that you can easily remember the IP addresses. So this will be again dot 2, always router number, and this will be dot 3. So this is again dot 100. This is dot 3, will give dot 3. So this is our lab study. So before starting with the lab, so tell me the routing table entries of R1. So what will be the entries in the routing table? Yes, online guys.
In R1, we have
Oh, wait,
two.
Janender. Wait, Janender. Yes, go in. Go in this mic problem. Okay. Janender,
Yes, sir.
tell me the R1's routing table.
R1 has
Yes.
directly connected routes that
What will be the entries?
1.0/24 and 12.0/24.
Very good. So we have 192.168.12.0/24 directly connected, and the exit interface. What is the exit interface? Let us consider it as 0 bar 0, 0 bar 1, 0 bar 0, 0 bar 1, 0 bar 0, 0 bar 1. Now, so it will be 0 bar 0. 1.0 changes. Then we have an entry 192.168.12.0/24 directly connected. Exit interface will be 0 bar 1. Then what about R2's routing table? Yes, Vinod. Yes. Which one? 192.168 dot 192.168 dots 2.0. No, always R2 will be having directly connected networks. Tell me for R2 which are directly connected networks. Is 1 is directly connected? Is 2 is directly connected? No, only directly connected are 23.0 and
12.0.
Yes. Correct? Clear? Okay. So it will be 12.0/24 directly connected, and the exit interface, that is 0 bar 0. Yes. 0. So one more entry. that is 192.168.23.0/24. So again, directly connected. We have 0, 0 bar 1. Done. Now what about R3? How many entries in R3? 2 or 3? What are those? Okay, we have 192.168.23.0/24, again directly connected. What is the exit interface? G0 bar 0. So one more entry, we have 192.168.2.0/24. So directly connected. What will be the exit interface? G0 bar 1. Yes, correct. So this is the by default entries. Now, how many static routes is required if PC1 wants to reach to PC3? How many static routes I need to create on R1, on R2, and on R3? Okay, let's design the lab, then we'll see that. Okay, let's go to the lab.
Need
So let me take 3 routers. We have R1, we have R2, and we have R3. To switch.
Can you take 4 outer? Might be I need to ask something because I'll take another outer as well.
Okay.
So is there any specific image for this access switch? I mean, not L3.
It's not, it's a normal layer to switch.
Okay.
So I'll take 4 virtual PCs. So the IP address between R1, VPC7 and VPC8 will be 192.168.1.0/24. So the IP address between R1 and R2 will be 192.168.12.0. IP address between R2 and R3 will be 23.0. And between R3 and R4, it will be 192.168.34.0. IP address between R6, VPC9 and VPC10 will be 192.168.2.0. Done. Now, bottom. .7. So this interface will be again .1. So on R2, G0 bar 0 will be .2. R2's G0 bar on interface will be also be .2. So this will be .3. This is also .3. .4. So we take .6 outer. So .6. .9 and .10. Yeah. First, we'll assign the IP addresses. First, provide the IP addresses. So IP 192.168.1.7/24 and the default port, that is 192.168.1.1. So IP 1.7 is created and the default gateway is 1.1. Go to VPC8. IP will be 192.168.1.8/24. The default gateway will be 192.168.1.1. Sure. Go to VPC9. IP will be 192.168.2.9/24. What is the default gateway? Default gateway will be 2.6. IP 2.9 and 2.6. Go to VPC 10. IP will be 192.168.2.10/24. What is the default gateway? Default gateway will be 2.6. Show IP 2.10 and 2.6. Yeah? So now proceed towards the routers. So R1. Hostname, interface Z0 bar 0. IP address will be 192.168.12.1/20. Right? No shut. Interface Z0 bar 1. IP address will be 192.168.1.1/20. Done on R1. So now go to R2. Interface Z0 bar 0. IP address will be 192.168.12.2/. One more interface, that is interface Z0 bar 1. And the IP address will be 192.168.23.2/. So done. Go to R3. Interface Z0 bar 0. The IP address will be 192.168.23.3/20. Interface Z0 bar 1. IP address will be 192.168.36.3/20. Now, final configuration on R6. Interface 0 bar 0. IP address will be 192.168.36.6/24. And interface 0 bar 1. IP address will be 192.168.2.6/. So go to R. So before configuring static routes, check the IPs. Show IP interface brief. This is a command in order to view the interface with the IP mappings. So Z0 bar 0, it is 12.1, and Z0 bar 1 is assigned with 1.1. Now check the routing table. Show IP route. Can you see? It has two entries, 192.168.1.0 directly connected. What is the interface? Z0 bar 1. And we have one more entry, 12.0 directly connected, Z0 bar 0. Clear? So go to R2. Show IP interface. So Z0 bar 0 is configured with 12.2 and Z0 bar 1 is configured with 23.2. Show IP route. Again directly connected. So we have 12.0 interface is Z0 bar 0 and we have 23.0 and interface is Z0 bar 1. Go to R3. Show IP interface. Z0 bar 0 is assigned with 23.3 and Z0 bar 1 36.3. Again the routing table. So it has two directly connected entries. That is 23.0 connected to Z0 bar 0 and we have 36.0 Z0 bar 1. Go to router 6. Show IP. IP interface 36.6 and 2.6. Show IP route. So we have 192.168 2.0 Z0 bar 1 and we have 36.0 Z0 bar 0. Now need to go to R1 and create static routes. So if you see the routing table, so does R1 know how to reach 23.0 network? No. It doesn't know how to reach to 36.0 network? No. And even it doesn't know how to reach to 2.0 network. Now, how many static routes you need to create?
3.
3. Good. You need to create a static entry for 23.0 network, 36.0 network, and 2.0 network. First, we'll see directly connected static.
So can we add only if at R2 there is a route for 192.168.2.0, okay,
Mhm.
and 36.0.
Mhm.
So that R2 knows about R6 and R3 networks, right?
Yes.
If we at R1 we just add only one route, which is
Yes, but full connectivity will not be there, right? Suppose if VPC7 pings to 23.3, it will not be pinged because it doesn't know 23.0 network, correct?
no, but R2 knows, right?
R2 knows.
At the end, R1 is going through via R2.
Okay, you tell me according to. So okay, you tell me. How many static
I'm
routes?
just asking it.
No, you are 100% right. I will tell you the problems. What will happen? Tell me what I need to create on R1. I'll come back to your point. I'll come back to yes. Tell me. IP route.
First you need to set route at R2 only, like for R3 to R6 and R61.
R6 to VPC9. That network,
Yeah.
right? So I need to create
R2 we need to add the two routes for
yes,
192.168 36.0 and 2.0.
36.0, 255, 255, 255.0. What is the next hop? We'll use exit interface. Exit interface directly connected.
Yes.
0 bar 0. Correct? In order to reach 36.0, I need to exit from Z0 bar 0.
Yes.
Enter.
Yes.
So I need to create one more static entry, that is 2.0, right?
Yes.
Z0 bar 0 again. Done.
Yes. Yes.
Okay. Show IP.
At
Show IP
R1
static.
you add. At R1, okay.
So
Okay.
we have two entries, 2.0 and 36.0. Done?
Yes.
Yes. Now go to R2. Okay. Tell me. How many entries here?
Sir, in R1 23.0 also need to be mentioned, right?
Yes. Come, we'll finish off with what is it. I'll tell you the problem as well. Darshan? Yes, Darshan.
Yeah.
Yeah, continue. On R2, how many static routes?
1, 2. Ideally, it should be 1, 2, 3 entries should be required.
Okay, tell me. IP route? Which network?
192.168.36.
36.0.
Yes.
255, 255.0. What is the exit interface?
Z0 1.
Correct? Enter. So one more static route for 192.168.2.0.
Yes.
Z0 bar 1. One more static route for 192.168.1.0 / 24. What is the exit interface? Z0 bar 0. I
0.
need to exit it from Z0 bar 0. Correct? Yes, we know. Clear?
Yeah.
Okay. So now created 3 entries, show IP, route, static. So I created entry for 1.0. What is the exit interface? Exit interface is Z0 bar 0. So I created one more static entry, 2.0. What is the exit interface? Z0 bar 1. So we have 36.0 as well. What is the exit interface? Z0 bar. Done? Now go to
Create R3.
Okay. So IP route. How many static routes?
So we leave, we can add 192.168.12.0.
Okay, 192.168.12.0 slash 24. What is the exit interface? Z0 parcel, right?
00, yes.
So one more static entry. That is 192.168.1.0 slash 24. What is the exit interface again? Z0 parcel.
00.
Done?
Yeah.
Show IP route. Static. So how many static entries we have? 1.0 and for 12.0. I'll come back. So now final static routes on R6. How many static routes here?
At R6, ideally we require 3. One
Then-
to with R2 to R3, R1 to
then
R2, and R1 to switch.
then that's what I was telling in the beginning. In order to provide full connectivity. So your what is the lab will be achieved. Your R2 knows how to forward to R3. But the problem is when VPC7 pings to 23.03 network, in R1's routing table, it doesn't have an entry for 23.0. So in order for the full connectivity on every router, you need to have 3 static routes. So your lab will be achieved. VPC7 will be able to ping to VPC10. But what about VPC7 pinging to 23.3 network? Because if you go and check the R1's routing table, go to R1. I don't know how to reach to 20.0 network. It will drop. R2 knows how to forward the packet.
But it forward to R2, right?
Yes, it
But-
will forward to R2. R2 will forward to R3. This lab will be achieved. I am telling you, no. So from VPC7 to VPC9, there is not at all a problem. But the problem is when VPC7 pings to 23 network, because R1 doesn't know how to forward the packet for 23.0 network. Clear?
23 can't be pinged, but other networks can
Yeah,
ping.
but I am talking about full connectivity.
No.
So my VPC7 should ping each and every each and every IP in my network. So then we need to create 3 static routes on R1, 3 static routes on R2, and 3 static routes on R3, and 3 static routes on R6.
I agree. I just
Yeah, you are right. You are 100%. I got your point.
no.
You are
We
100%.
are we able to ping from VPC7 to VP9 with
Yes,
the
yes, that is achieved. That is achieved. If you go and
Oh.
create on R6 only 2 static routes for 12.0 and 1.0, your lab is achieved. But the problem is we don't have full connectivity. Clear?
Okay. Because
Clear,
it
Darshan?
was asked in an interview, so that's why
Correct. You are 100%.
I was not able to answer it. So
Oh,
that's
this
why.
question only. So it's just
Yeah,
nothing. Just go to the routing table and check the entry, right? If there is no entry, then it will drop the packet. So you need to configure 3 static routes in order for the full connectivity.
So for full connectivity, we need to configure,
Yes,
but
yes.
for the partial, we can able
Yes.
to ping it, but
Yes.
it
2
will
is
not
more than
drop.
enough. Yes,
2 is more than enough.
yes. I
So-
hope it is clear, Darshan. Yes, Manish?
Chetan, for the minimum routing to be configured for this to work,
Mhm.
I need 2 on R6 and 2 on R1, right?
Yes, correct.
Okay. And
And
as you
3 on
told
R2
for
and 3 on
3.
R3.
Okay, got it.
You
Thank
are
you.
right.
All good, yeah, thanks.
So now,
Let's see. I'll try to on GNS and we'll ask.
yes. Please ask me tomorrow. Okay. So IP route. So let me create 2 and then we'll see the point. So 12.0 slash 24. What is the next stop? 0%. Sorry, exit interface 0%. One more static route for 1.0. Done. Show IP route static. So I created static route for 1.0 and 12.0. Now go to VPC7 and initiate a ping to VPC9. 192.168.2.9.
Can you also explain how packet moves from VPC? Like we know the static routing, right? So
Yeah.
what all it will check when it reaches to R1, how
Yes,
the MAC address changes with the
That I showed you,
changing
right?
the-
That I
Yeah.
told you in the beginning. I'll show you here also. One.
Yeah.
So okay. So now, so why the packet is dropping? Go to R1. So it wants to forward the packet to 2.0. What is the exit interface? Exit interface is Z0 bar 0. Correct? So now it will forward the packet. Why we call directly connected static route is, can you see here? When I created a static route, it is direct connected. Means there is no recursive routing in directly connected static route. Clear? Now. So now it has forwarded to R2. So go to R2. I have a static route exiting from Z0 bar 1 interface. This is also fine. Go to R3. R3 needs to have a static route for 2.0. Can you see R3 doesn't know how to reach to 2.0. So IP route 192.168.2.0/24. So what is the exit interface? G0 bar 1. Show IP route static. So now I know how to exit. Now R6 is directly connected. So in the same way, go to R6. Check. I know how to reach to 1.0 and 12.0. So go to R3. R3 knows how to reach to 12.0 and 1.0. So R2 as well. And R1 as well. R1 is directly. Okay. Let's initiate a page. Successful. Now, how the packet is put. So now, now you check the problem here. So go to R1's routing table. Go to VPC 7. What did it say? Why? Because R1 doesn't know how to forward the packet to 23.0. Can you see? That's why for full connectivity, we need to have 3 static routes. So let's create 3 static routes. So IP route. So go to R6. IP route 192.168.23.0/24. Will I be able to reach? I hope this part is clear. Now, how the packet is done. Source IP. And what is the destination IP? Two 2.9. What is the source MAC? It will be the VPC 7's MAC. What is the destination MAC? I don't know the destination MAC of the default gateway. So we went to R7 and provided the default gateway. Now to send an ARP request and ARP reply. So in ARP request, source IP and destination IP. 10.0.0.1, 10.0.0. Sorry, it's not 10, it's 192. 168.1.7 and destination IP will be 192.168.1.1. Source MAC, I know the source MAC, that is 8, but I don't know the destination MAC. Again a broadcast, but ARP request. It is requesting for ARP because host 1 doesn't know how to reach to other networks. So it will just give a ARP request to what is say the default
Gate,
gate.
gateway, yeah.
Correct. So what is the destination MAC? Destination MAC, I don't know. Again, if this is the ARP request, then ARP reply. ARP request is always broadcast. What about ARP reply? Source IP will be 192.168.1.1. Destination IP will be 192.168.1.7. What is the source MAC? Source MAC will be, let us consider as B. So it will be B, and destination MAC will be A. So every time your MAC changes. This is your ARP request. And this is your ARP reply. Okay, so like this, a ARP request, ARP reply, ARP request, ARP reply, ARP request, ARP reply, ARP request, and clear. So anybody has any doubts? Yes.
Repeated in initial state, what would be the destination MAC? In first request?
FFF, right? ARP request. What is ARP request? It's a
FFF.
broadcast, right?
Yes.
Yes. Initially, it will be FFFF. That's why, can you see first entry will always flop? Because of resolution. It is resolving your destination MAC address with the help of known IP address. This is about directly connected static route. So the next type of static route we have.
Sir.
Yes.
Hello. While configuring the static route, you give exit interface. So is it more preferred than the next hop IP address?
Next hop will be recursive routing. I will show you the next hop. Then you will only decide what to use. Best is fully specified, both exit interface and static route. Clear?
Okay.
Just I'll quickly show you. Just go here. Just remove this. Push over pipe section. Static. Include static. River. IP. Okay. So no, let me quickly remove this. So go to art. Go to R6. No, I will go to R1 and create static using next step. So IP route 192.168.23.0. What is my next stop? Yes,
12.2.
12.2. 192.168.12. Enter. So 36.0, same next stop, 12.2.
Yes.
And for 2.0 also, we have the same next stop. Done. Show run pipe section. Now see the problem. Show IP route. Static. Okay. Now check the static route. So I want to reach 2.0 network. So go to 2.0. Here it is 2.0. So what is the AD value? 1. This is the metric. Now check the next hop. What is the next hop? 12.2. Now where is the exit interface? Now again, it will check for 12.2. Again, at what is a lookup? Where is 12.0? So can you see here? 12.0. What is my exit interface? It should do double lookup. That's why we call it as recursive. So first, it will check the next hop, that is 12.2. Now, how to exit it? So it needs to check again the 12.0 as well. This we call it as a recursive routing, double lookups. So this is the major disadvantage in recursive static route. It needs to do double lookups in the routing table. That's why most widely used is fully specified static route. I hope clear. So in fully specified static route, you will give both exit interface and next hop. I hope this part is clear. With recursive static routes, anybody has any doubts? Yes, online guys. So we need to create T3 static routes on R2, R3, and R6. Yes, tell me.
So apart from it has double routing, is there any other difference also between providing interface and next hop IP?
So this I know. You tell me. This is the only difference because the name only says recursive. Do double lookups.
Okay.
Clear?
Yep.
Clear?
Yes, sir.
Any other doubts?
No, sir.
All right. Now, so this is your task. So I just showed you what I remember recursive. So you need to provide me full connectivity. So now you need to go to R1 and create 3 static routes, one for 23.0, 36.0, and 2.0. So on R2, we'll be creating again 3 static routes, 1.0, 36.0, 2.0. What about on R3? You need to create static route for 12.0, 1.0, and 2.0. So in the same way, go to R6 and create 3 static routes, one for 23.0, 12.0, and 1.0 using next. That is your first task. Please make a note of the task. So no task, no class tomorrow. So please send me to my email IDs. Please finish the task.
Okay. Okay, Chetan.
At least in 2 days. At least by today is Tuesday. At least by Thursday. Please submit it. Please send me to my email IDs. Please.
One task only, right?
We have to one more task. Next, I will show you next hop and directly connect it. Right? That is also your task. I will show it on only R1. So your task is to configure on R2, R3, sorry, on R2, R3, and R6, and you need to send me the screenshot to my email ID. Yes, my email ID is Chetan at networkersHome.com. So no, don't send it to here. Send it to my email ID Chetan CHETN GORABAL 8@gmail.com. So this is my email ID. So please finish the task in 2 days and submit it to my. Please share your email ID. Yeah, this is my email ID, Janendra. CHETN GORABAL 8@gmail.com. This is my email ID.
Okay, sir. And sir, do we have any Google Drive setup for that?
Yeah, I will provide it. Wait. Let me finish the class. I'll probably wait at the end of the class. Clear? Now your second task. So let me go to R1. I hope my email ID done, noted. Okay, now. Okay. Okay. So now, how to configure fully specified? Do show run pipe section. No. IP route 192.168.23.0/24, and first you need to provide the exit interface and the next stop 192.168.12. Enter. IP route 192.168.36.0/24. What is my exit interface? 0/0. What is the next stop? Again, it is 12. One more static route, that is 2.0. Check show IP route. Check for 2.0 network. There is no recursive routing because it knows both exit interface and next stop. This is about fully specified static route. So yes, guys, anybody has any doubts? So your first task using next hop. Second task using fully specified static route. So you need to send me the screenshots to my email ID by Thursday. So you have 2 days time. So take 4 routers. So IP, provide the IPs first, then do the lab and send me the screenshots. So what screenshots you need to send? So I want the screenshots of show run pipe section IP. I want to know what static routes you have created on each and every router. Then connectivity between VPC 7 and VPC, what do you say, 9. I want the full connectivity. So please send me the screenshot. I hope that part is clear. So just tell me, guys, who doesn't have drive access, please provide me your email IDs, name, and the mobile number and the course enrolled in the chat box.
Sir, I had provided yesterday.
Yeah, yesterday provided is already, I have already shared, right? You have got it, right, Balaji?
No, sir.
No, then share it once again.
Okay.
So whoever has not got, Sunita, please share everything at once. Your name, email ID, mobile number, and the course center.
So I have a doubt.
Yeah, tell me.
Sir, in which situation we provide both this interface, exit interface, as well as next hop ID?
Yes. It depends on the task again. So in the task, it will be clearly mentioned what you need to do, whether it is a recursive or directly connected or what is it, fully specified. So most of the cases we use fully specified.
But I saw in many cases, 99%, I see only next hop, recursive one.
It depends
Never
on
see-
again the requirement.
No, requirement, how we can say requirement? What do you mean by requirement?
Then you tell me what do you mean by this one? What you say? Why they are using only that recursive? Why not fully specified and why not directly connected?
That's what I asked you, but you again asked me.
No, that only I'm telling you, no. So it depends on your requirement, right? So you are providing, it is a static route. We go and manually configure, right? So it's not like dynamic routing. It is using any bandwidth or delay to what to say, to select the destination path or something like that. We are going and manually creating. So I told you the disadvantage of what is the disadvantage of recursive? What is the disadvantage of your what is say directly connected, and what is the advantage of using fully specified? So now it depends on the completely on the requirement.
Okay.
Okay.
Let's
I hope
see.
everybody has provided. Okay, guys. Thank you. We'll meet tomorrow.
Thank you, Chetan.
Thanks.
Thanks, sir.